Advanced Financial Modeling, Multi-Period Portfolio Modeling, Learning Objective number 5. We're going to create an Excel macro stochastic portfolio model with multiple periods, changing asset allocations and contributions to calculate things like the probability I'll have enough money at retirement. So here's the model. Let's jump to the spreadsheet and create it. So here we go. Here's the model we started creating before with our income, savings rate, inflation, and so on. And so far we calculated the expected portfolio value at, say, age 65. I expect to have $1.693 million. But nowhere in this model was risk accounted for. So what I want to do is combine what I've been doing in the last modeling section with this portfolio model and create a simulated portfolio. So remember, this expected portfolio value is the prior value times 1 plus the mean plus the contribution. I'm going to have the same formula here, but I'm going to make this a random walk model. I'm going to say the initial portfolio value, or the prior portfolio value times 1 plus the mean portfolio, which we've calculated before, plus norm S inverse rand, that's that random number, times the standard deviation. Well, forgot one more thing there, and then I'm going to add my contribution. Okay, there you go. So there is no randomness in the first one because we had no initial portfolio value to get a simulated return on. So it is the prior portfolio value 0 times 1 plus the mean plus a random number times the vol plus a contribution. Now what I'm going to do is copy that formula down. And now what I have here is a simulated life of portfolio values. Notice here I'll look at this age 65, I expect 1.69, but every time I hit F9, I got 16, 52, 17, 24. So you can see the portfolio value could be much different than what I expect based on the standard deviation of the portfolio. Where did the standard deviation of portfolio come from? Well, it came from my asset allocation rule and the standard deviations of stocks, bonds, and bills. So what I'd like to do is then kind of explore this random portfolio value and see if I have enough money to retire on. Notice this formula, I need to add, it adds one more thing to it. There are my contributions, but also remember that I already have built in there the withdrawals. So it's kind of like a negative contribution. So what you see is sometimes you run out of money. So if you keep hitting F9, you can see when did I run out of money? Well, it looks like this, it was 90, I ran out of money. This one, 85. You know, there's some ages that are hidden there because I've hidden some rows to show this better on the screen. Oh, looks like this one I ran out of money at 63. That's not good. So how could that happen? Well, you had a bunch of random shocks, a lot of negative Z's associated with some bad economies and bad stock markets, and you just didn't have enough money. So I now have this model. What could I do to try to think about the risk of this portfolio? Well, I'm going to write a macro. It's going to be called sim return 5,000. It's going to do a loop for I equal 1 to 5,000, next I. And it's going to do 3 calculations, not just 1. It's going to take whatever is in cells 510. And so let's look, where's 510? 5th row, 10th column. I can come over here and see here 5. If you look at the top left corner there, you can see 5th row and 10th column. It's this number right here. What is this number here? It is just the portfolio value at age 65, which is when I plan to retire, this says, this model. So there's my cells 510. Notice every time I hit F9, I have a new portfolio value. Okay? What's in cells 710? Well, it's a count if, and all it's doing, it's trying to figure out what age your portfolio ran out of money. So it's counting how many of the observations are greater than 0, and then adding them to your current age. And that tells you at what age your portfolio ran out of money. So every time I hit F9, in this scenario, I wind up retiring at $800,000 and my money runs out at age 76. Hit F9. This one I wind up with $1.8 million and I run out of money at 79. F9, $2 million, and it lasts me till age 99. So this is the randomness of life that we can't control. Some of them are really great. Let's find a great life here. I want to see if I can get to 3 million. This one I wind up with 2.9 million. So for whatever reason, a lot of random Z's are very positive, and I have enough money to live till I'm 101 years old. So here's what I'm going to do is I'm going to collect this number and this number 5,000 times. So it's 5,000 possible lifetimes. And the loop is for I equal 1 to 5,000, next I. Whatever's in 510, right, that's this cell right here. Put it here, then here, then here, then here. Whatever's in 710, which is the age my portfolio dies, put it here and here and here and here. So it's going to put numbers here, then here, then here, and then I'll have 5,000 possible lifetimes. If you look at Alt F11 and look at sim return, there's my sim return. So it's a sub, it's ready to run. So let's go ahead and run it. I'm going to hit Alt F8 and click on sim return, or I can go to developer macro and run sim return there. But I'm going to show you one other way to do it. Create any art object. I created an art object of just a star. So you can just insert any kind of shape you want. Then I right click on that shape and I clicked on assign macro. And then I select sim return 5,000. Now this art object has the sim return 5,000. So it's just kind of a cool way to have a macro button in your worksheet. Now all I have to do is click on this and I start getting my 5,000 possible lifetimes. Each lifetime it's going to record the portfolio value and the age in which the portfolio runs out of money. Notice I have one more line of code in this macro. Cells 914, 9th row, 14th column. That's actually right here. This is 914. It is 5,000 minus I. This is just a cheap trick I've created to keep track of the macro running. So the first time it runs it, it's 5,000 minus 1, then 5,000 minus 2, and so on. So you can see this is counting down from 5,000 to 1 to run the macro. So I'm going to let this run for a minute. I'll be right back. I'm going to pause it while this is running. Okay, this is almost run down to 0. One reason why this is running so slowly is I have other worksheets open. If you want to run a macro, I recommend closing all other worksheets because it is recalculating every worksheet that's currently open, every workbook. All right, so I have my 5,000 portfolio values at retirement, 5,000 ages in which the portfolio has been liquidated, it goes negative. So the last thing I would like to do is make a few calculations. On average, what was my portfolio worth? So I can just do an average. But before that, let me do something else here for fun. Let's give this whole range here, oops, Control Shift up, let's go back to the top. This might help you in other situations. let's give all of these numbers here from, was it L13 down to L5012. I'm going to give them a name of ports, and I want to give these 5,000 names. I selected the entire column of 5,000 ages, and I'll just call it ages. Whoops, let's go back there. Let's call that ages. So I got ports and ages. That's going to help me. So I can do equals average ports. So the average, on average, I should have $1.69 million. All right, which is almost exactly what I expected, right? We determined, our deterministic model said I should have $1.69 million. But the point of a Monte Carlo simulation isn't to get the average. I knew what the average is going to be. What I'm really interested in is some probabilities, which I'm going to get to in a second. All right, so that's my average portfolio value. We can do the average age in which portfolio goes away. So I'll say average ages, which is just the average of that column. Looks like it on average it'll last me 84.6 years, which is pretty close to what this says, right? 1.69, 86 years. But here's the real benefit of this model. Let me just get rid of these. The benefit is, what's the probability that if I'm expected to live to age 92 based on my health condition, what's the probability I'll have enough money? What's the probability that the portfolio will last more than 92 years or greater than or equal 92 years? Well, I can do this, equals count if. And then I can say, well, the range is ages, comma, greater than, we'll just say greater than 92. Close, divided by 5,000. So what that says is there's a 24% chance the portfolio will last over 92 years. All right, so that's not good because that also means there's a 76% chance I will not have enough money. So that's what this allows me to do. Now what I want to do with these other two columns out here is get smallest and largest. So this is kind of an interesting thing we can do here. 10% small and 10% large. So I want to go back here, my model. I'll copy this for formats, and then I'll delete. And we'll say 10% small, 10% large. So to really explore this distribution of possible portfolio values, it might be nice to see kind of what's the 10% highest and lowest of these. So what I can do is say equals small, put in the array name, that's just my ports, comma, there are 5,000 observations. I'll just type in 5,000. I want the 10% smallest, so it's 500, so I'll just put 5,000 times 0.1. So the 10% smallest value in that array is 880,000. So there's a 10% chance I retire with 880 or less. I'll copy this formula, but change the word to large. The 10% largest portfolio, so 10% of 5,000 is 500, is 2.7. So what this says, there's a 10% chance I'll retire in less than 880 and a 10% chance I'll retire on greater than 2.7 with an average of 1.6. And I can do the same thing with ages. I can say, well, equals small, and that's ages, comma, 0.1 times 5,000. There's a 10% chance my portfolio will only last till age 74. I'll copy that, change that to large, Again, Excel's small and large functions are finding the largest X% or K% or smallest K% in an array. And there's a 10% chance my portfolio lasts till age 101 or more. So this really allows you to think about this retirement plan. And if I'm uncomfortable with these, I could rerun them. So what if I say, you know what, I'm uncomfortable with only a 24% chance of having my money last for uh, uh, 92 years. Maybe I should save 15% of my income. And then I could rerun and see what it does to these numbers. I'm not going to do that because it's going to take a little while. But this is what it allows me to do. Also, I could also change my asset allocations. Well, what happens? What if I am a little more aggressive on stock or a little more conservative? What if I use 100 minus my age or 125 minus my age and split the difference in bonds and stock? What if I change my assumption on the stock market or volatilities? So this allows me to see what it does to my probability of, say, outliving my money, which is, say, an average age of 92. All right, so in this section, we created an Excel macro stochastic model, probabilistic model with multiple periods, changing allocations and contributions, and we explored the distribution of returns of the portfolio value and ages in which the portfolio liquidated.